Hello students, this is the recording for the 5B lesson, Factors Affecting Solubility. Let's go ahead and do a quick brain stretch on this vocabulary that we learned in the previous lesson, solvent, solute, and solution. Go ahead and take a moment. You need to match up which of these is what you have less of that gets dissolved like salt, what is also known as a homogeneous or uniform mixture, and what is the thing that you have more of that does the dissolving like water. Pause the video and continue playing when you have an answer. All right, so taking a look here, you should be able to know that at this point, the solvent is what is doing the dissolving. It is, in fact, what you have more of. A good way to remember this is, remember, we have a memory trick that the word solvent has 7 letters. And so this is actually like the medium-sized word. Right, so it's not what you have the least of, it's not the overall result, but it is what you do have more of, right? Solute, on the other hand, only has 6 letters, therefore it's what you have less of that gets dissolved, so salt is a solute. Water would be the solvent. Again, thinking about how water is often called the universal solvent. And once you mix those together, you get the solution. Remember, solution is 8 letters. This is the longer word. And so that's the overall putting them together, right? So solvent plus solute gives us the overall solution. Again, this is also known as a homogeneous or uniform mixture. Remember, homo meaning same. And so this means that every sample looks the same. So if you dissolve salt into water completely, if you take a sample from the top, the bottom, the left, the right, the middle, every sample looks the same, tastes the same, etc., etc. So this is our answers right here, again, if you want to review those. But let's go ahead and talk about some announcements. There are only 9 days left of the trimester. We are officially into the single digits, crazy to think about. Today is Wednesday. We're going to be talking about 4B, factors affecting solubility, and completing the 4B notes. All right, so again, this is where we're at. You do have an exam coming up. Don't forget that STAR 360 should be done on the day that this lesson is due, right? So you should have done math during period 3. Keep in mind that you are still responsible for anything that happened during your period 3 course, so please make sure that you still watch the recording. And for our class, complete the notes if you were missing for the period 3 class for our class. Remember that we did move the exam so that it didn't fall during STAR 360. So the exam, we have gone into Unit 5 straight from Unit 4, and now our exam will be on Wednesday, June 2nd. It is technically due on June 2nd, but will not be zeroed out until June 3rd. And then you have a week to make up any missing work. You should focus on projects and exams since those are worth 70% of your grade, right? You cannot pass without them, so please make sure that those are your priority. Don't waste your time on other things if those things are not yet done. Keep in mind that I am now on maternity leave and Mrs. Sepulveda is actually back. So Ms. Sepulveda is the other normal physical science teacher. She was on leave for this trimester, but so she can absolutely help you with projects and exams as well. So not only can Mr. Bangle help us, who's been with us this entire trimester, but now Mrs. Sepulveda can also help you, and this is her contact information. Again, if you were on my roster, you are now on her roster. I know it's been a bit of a shuffle the last couple days, but this is how it should be until the end of the trimester. All right, so let's talk about our objectives for today. We should be able to define saturation and solubility, explain how changing temperature affects the solubility of a solid solute versus a gaseous solute. Again, working on the 5B notes. So at this point, if you haven't already, make sure that your 5B notes are open and started. Remember that you can get to those from the Grades tab. Everything is always in the Grades tab. That is your one-stop shop. Okay, let's go ahead and start off with a brainstorm. The question that we're going to take a look at while watching this video is, what do you observe happening to the sugar in cold water versus hot water? So let me go ahead and pop this up on the board for us, and let's watch this.
On a hot summer day, we all feel like drinking something cold. And if the drink is sweet, it is so much the better. Today we will examine whether sugar dissolves more in cold water or in hot water. For this, you take 2 glasses. Fill one with cold water and the second with hot water. The right glass has hot water and the left glass and the middle glass is cold water. Take a sugar cube and put a sugar cube each in both the glasses. Then wait and see in which glass the cube dissolves first. You will see that there is much more activity in the hot water as compared to cold water. The sugar cube will dissolve much more quickly in hot water. If you don't have sugar cubes, you can repeat this experiment with ordinary sugar.
All right, so take a moment, pause the video, and think to yourself, what did you observe happening in this video? All right, so what you should have noticed is that in the hot water, the sugar cube dissolved a lot faster, whereas in the cold water, it dissolves much more slowly. All right, so we're able to see that temperature has something to do with how quickly things dissolve, and that's something that we'll be taking a look at today. So let's quickly review. Again, this is something going back to our brain stretch today, that a solute and a solvent make a solution. Remember, solute is our shorter word, so it's what's getting dissolved, what we have less of, kind of like our salt or our sugar or our drink mix, or our chocolate milk mix, right? Solvent, on the other hand, is what is actually doing the dissolving. Again, it's what you have more of, so in this case, like water or milk, it's whatever is the actual thing that's doing the dissolving. Now, we also learned about this term saturation, and that term saturation is when there's no more room for any additional solute in your solution, and so any extra solute gets settled to the bottom. So you can see an example of that right here. Now, an important thing to understand here is saturation is kind of like the vocabulary term of where this point happens. We're going to learn a little bit about the math term in just a moment, though. All right, so taking a look here, so solubility is the new term that we're learning today, and solubility is an actual amount. So it's the maximum amount of solute that can dissolve into a solvent. So these two things are related to each other, right? At saturation, no more solute can dissolve, and then solubility is going to be what is that maximum amount. This is really important to understand, though, that solubility is an actual number, whereas saturation is just a description. So saturation is the point at which things stop dissolving. Solubility is the actual number of how much you have at that point. Okay, so solubility is a number. It's measured in grams of solute per 100 milliliters of water. Sometimes you'll see grams instead of milliliters, but just know that grams and milliliters of water, 100 grams is the same as 100 milliliters. So these can actually be used interchangeably, meaning they're synonyms to each other. Okay, so taking a look here, we can see some examples here. So sodium chloride, which is just regular table salt, NaCl, has a solubility of 35.7 grams per 100 milliliters of H2O. So if you take 35.7 grams of sodium chloride and put it into 100 milliliters of water, then at that point you have the maximum amount of solute that can dissolve. And now if you try to add any more, the rest of it is going to fall to the bottom because you are at saturation. Okay. Now let's go ahead and talk about solubility of lead chloride. Its number is 1 gram per 100 milliliters. This is interesting to notice that you can actually have different amounts that can dissolve into a solution. And zinc chloride right here is the most soluble of all of these. It can dissolve 200 grams for every 100 milliliters of H2O. Please note that this is at like a regulated temperature, so this is at like room temperature. Again, we're going to see that temperature does actually change the solubility of these various different things, all right? So that's going to be important to understand later. All right, go ahead and pause the video and work on this, right? So we have 4 terms here: saturation, solubility, solute, and solvent. So you need to know what is the substance that gets dissolved that you have less of, and what is the maximum amount. Again, amount means you should be looking for the number term of solute that can dissolve, measured in grams per 100 milliliters of water. When a solution can no longer dissolve additional solute, so extra solute settles to the bottom. Again, this one's not a number, this one's just a description. And then finally, the substance that does the dissolving, what you have more of. All right, go ahead and pause the video, match those up, and then continue playing when you think you have the right answer. All right, so let's take a look at our answers here. So again, saturation and solubility are related, but remember that saturation is just the actual description. So this is the point at which a solution can no longer dissolve any extra solute, and so it all settles to the bottom. Now the actual number at that point, again, is called the solubility. So this is a maximum amount. It's an actual number per 100 milliliters of water. Solute, again, is the short word. It only has 7 letters here, so this is the substance that's getting dissolved. Oh, sorry, 6 letters, whereas solvent has 7 letters. It's a little bit of a longer word, and so that's the thing that's actually doing the dissolving. So again, universal solvent would be like water, whereas this would be like something like salt. All right. Let's go ahead and take a look at our next question. So this is a graph, and this graph shows the solubility of various chemicals at various temperatures as well. So what we're going to see here is that temperature has an effect on the solubility of different chemicals today. But let's go ahead and first read this graph for what's happening at 20 degrees Celsius, which is the same as room temperature. It's about 70 degrees Fahrenheit. All right, so we're going to go ahead and take a look at 20 degrees Celsius on our graph right here, which is this area right here. All right, so we're going to be taking a look at everything that is on this 20-degree line right here, going up and down. Okay, now taking a look at that, we need to go ahead and find these 4 different substances here. All right, so we need to find potassium chloride, potassium nitrate, lead nitrate, and sodium chloride. All right, so let's go ahead and talk a little bit about that. So taking a look here, potassium chloride, right, is KCl, and you can see my dark blue line shows me KCl. All right, so what I'm going to do is I'm going to go up from 20 until I hit that KCl line. And once I hit that line, I can just kind of look to the left and figure out about what is that solubility. Again, the solubility right here is on the left. Grams per 100 milliliters of water. You'll notice again that it says 100 grams of water, but again, grams and milliliters for water are identical to each other, specifically for water. All right, go ahead and pause the video and think to yourself, based on this, what do you think the solubility of potassium chloride is at 20 degrees? All right, so you should see here that this is about 32, 33. All right, so I'm going to go ahead and put 33 grams per every 100 milliliters of water. Let's go ahead and take a look at our next one. All right, so now our next chemical is going to be potassium nitrate. So I need to first find the KNO3 line, which is this green line right here. All right, we're going to go up from 20 degrees Celsius. And once we hit that green line, we're going to look to the left. Pause the video and think to yourself, what would the solubility of this one then be at 20 degrees Celsius? Well, you can see that's pretty much exactly on the 30-degree line here. 30-gram line here. So I'm going to go ahead and fill in 30 grams right there. Now let's go ahead and try the next one. So lead nitrate. All right, lead nitrate is PbNO3 2. So that's going to be this yellow line right here. Okay. And again, we're starting at 20 degrees. Go ahead and try doing this one a little bit more on your own. Pause the video. Once you have an answer, go ahead and continue playing. All right, so if you look up from 20 until you hit the yellow line, you should see that it falls a little bit above halfway between 50 and 60. So I would probably call this like 56 grams per every 100 milliliters of water. All right, and then the last one, go ahead and try to do the last one completely on your own. Again, you should start at 20 degrees. You need to find the sodium chloride line, NaCl. Go up until you hit that line, then look left, and that will tell you the solubility. Take a few moments, pause the video, and continue playing once you have an answer. All right, so taking a look here, again, you should have noticed that the light blue line here is sodium chloride. Again, we're starting at 20 degrees. So if I go up until I hit that light blue line, and then looking over towards the left, again, go straight to the left. I know the line kind of curves, but you do need to go straight to the left. And that looks like it's hitting about halfway between 30 and 40. So I would call this 35 grams per every 100 grams of water. So this is the solubility of each of these. All right, so that looks great. All right, so we have our solubilities right here. Now you need to think about, therefore, which of these has the highest solubility. So take a look at their numbers and figure out which one is the highest. Again, pause the video, continue playing once you have an answer. Well, taking a look here, 56 is definitely much larger than all these other numbers, so this means that we can dissolve lead nitrate, a lot more lead nitrate per 100 milliliters of water than we could of potassium chloride, potassium nitrate, or even sodium chloride. All right, so this is going to be our answer to number 3. Go ahead and pause the video and continue playing once you have that filled in. All right, so what I want you to think about now is in what type of tea does sugar dissolve best? Do you think sugar dissolves best in iced tea, room temperature tea, or hot tea? Pause the video until you have an answer. Okay, well, taking a look here, the answer here is hot tea. So if you think about sometimes at the restaurant, for example, if you try to dissolve sugar into something that is ice, the sugar is really gritty and it sticks around for a long time. You have to try to stir a lot. It takes a long time for it to dissolve. Whereas we already saw in our previous video today that hot water or hot tea, in this case, which is mostly hot water, is going to definitely going to dissolve sugar a lot faster. So this is the answer to number 4. Pause the video, continue playing when you're ready. Okay, so let's talk about the relationship between temperature and solid solutes. So here's the deal. This is actually, in general, a direct relationship. So this means that as you increase the temperature of your solvent, meaning what you're dissolving your stuff into, all right, so as your water gets hotter, for example, or your tea gets hotter, then your solid solute is also going to have increased solubility, meaning more of it's going to dissolve and it's going to dissolve faster, right? So more can dissolve. Okay. On the other hand, in something that's really cold, right, like our cold tea, it definitely does not dissolve as quickly, nor can we even dissolve quite as much. So this results in decreased solubility, so less can dissolve. Now again, this is generally true, right? So it's not always true, but for most cases this is true. So for solid solutes like sugar, sugar is a solid, as you increase the temperature of the solution overall, this means that these solvent molecules, the things that are doing the dissolving, have more energy. And so they actually begin to collide a lot more with our solute right here. And as they collide a lot more, because they have more kinetic energy, they can actually break that solid solute apart more easily. It's kind of like if you think about like using a hammer fast versus a hammer slow. Right? Again, the faster you can hammer that solid solute, the faster it's going to break apart. And again, the hotter the solvent is, the more it can hammer at that solute, that solid, and begin to dissolve it. So that should make a lot of sense. Again, we should be pretty familiar with how hot and cold work with things like sugar. This is number 5. Pause the video, continue playing when you're ready. Okay, now let's go ahead and think about this. So what type of soda do you prefer? Do you prefer cold soda, room temperature soda, or hot soda? This is kind of just an opinion. There's not really a right answer, although there is. I will definitely think you're a monster if you choose one of these. Go ahead, pause the video until you have an answer. All right. Well, I personally would definitely say that cold soda is better. And if I had to compare room temperature versus hot soda, I would still choose room temperature over hot soda. So I would definitely rank this as number 1, number 2, and let's never drink hot soda. But let's go ahead and talk a little bit about why that is. So think to yourself, why do you prefer cold soda? Pause until you have an answer. All right, well, I would say that a lot of us prefer cold soda because it's more refreshing. So first off, it's fizzier, right? Which means that it has a lot more of those bubbles. You can kind of see those bubbles here and here. As well as just sometimes cold things tend to be more refreshing, right? You generally don't want something like hot in the middle of the day, so cold soda is going to feel more refreshing in the middle of the day, right? But one of the key points I want you to know is that cold soda is fizzier. If you have hot soda or soda that's been sitting out for a long time at room temperature, it no longer has any bubbles. So cold soda keeps its bubbles for much, much longer. Let's go ahead and talk about why that is. So again, the colder you are, you actually have more bubbles. And these bubbles are actually just dissolved gaseous solutes. Okay, so let's go ahead and talk a little bit about why that happens. So this is actually an inverse or an opposite relationship. This is different than what we just talked about. So what happens here is that this time, as temperature of your solvent or solution increases, your gaseous solute actually decreases. And this should make sense because remember that hot soda doesn't have fizz or bubbles, right? So it no longer has that gas inside of it, okay? It's losing that gas very, very rapidly, all right? So rapidly that if you like boil soda, you'll see the bubbles all come out very quickly. On the other hand, if you decrease the temperature, like cold soda, then you do actually have an increased solubility of gaseous solutes. This means that you have more bubbles, right? Which again is why it's part of the reason why cold soda is more refreshing. Now let's go ahead and talk a little bit about why this happens. So for gaseous solutes, like the bubbles in soda, those are carbon dioxide bubbles. As you increase temperature solution, this actually also increases the temperature of those gases. So our gaseous solute also begins to have increased temperature. So now our dissolved solute also has more kinetic energy, and now they can actually begin to escape the solution, resulting in decreased solubility. Like I said, if you try to boil soda, those gases escape very, very quickly. So you can see that down here, right? You can see that the gas right here is beginning to escape a lot more than it does over here. Right here, you can see that there's a lot less escapage going on. All right, so again, this is actually an opposite relationship. Go ahead and fill in number 6 and then continue playing when you're ready. Okay, so this is a real life connection here, which is that our oceans are experiencing this similar phenomena to our soda. So as we have climate change, so overall the temperature of the earth on average has been increasing during the past few years, this means that the oceans are also getting warmer. All right, so once you have warmer waters, that means that you have less dissolved gas. Now for our soda, that just means less CO2 gas. Our hot soda is not as fizzy, not a big deal, it's kind of gross. But the problem is that when we talk about the ocean, the gas that we're most concerned about is the oxygen, because as you have warmer waters, oxygen is a gas, oxygen also begins to escape more. So we have more oxygen that now has a lot more energy leaving our oceans, and that means that we have less dissolved oxygen within the water here. Now, animals use that oxygen in the water, so if you have less oxygen for animals, they begin to die. So what we can see here is that we have a lot more animals dying within our ocean, which not only means that they're dying, but this is actually also increasing this dead zone. All right, so there's an area of the ocean where a lot of dead matter goes. So as it increases the dead zone, it actually also decreases the space in which these animals have to live. So now you have decreased space with additionally decreased oxygen, which means that things just begin to die at faster and faster rates. So part of the reason it's important to think about why we want our oceans to stay cold is because this actually improves the ecosystems of our oceanic life as well. Now again, I do want to remind you that generally the solubility of solids versus gases versus liquids, all right, generally solids and liquids will have higher solubilities at higher temperatures, right? So over here we have higher temperatures. Okay, higher temps. And solids and liquids, we didn't really talk about liquid solutes, but solids and liquids will be better at dissolving. And again, this is because they, the solvent, right, so like the water, can break apart. Has more energy and can break apart the solid solute, all right, like salt, okay? On the other hand, all right, when you're dissolving gases, yes, the solvent does have more energy, but the solute also has more energy, right? So the solute, in this case, like our CO2 bubbles in soda, soda would be the solvent, also has more energy. And gases are interesting because remember, gases actually want to escape. So now that the solute, gaseous solute, has more energy as well, now it can escape the solvent, okay, which in this case is the soda. All right, so again, these actually generally have opposite trends. Solids increase their solubility as they get hotter. Gases decrease their solubility as they get hotter. All right, so let's go ahead and match these up. You should know what happens in a cold solution versus a hot solution. So taking a look here, you can see what increases the solubility of a solid solute like sugar. Think about, is a cold solution going to increase the solubility of sugar or a hot solution? Then think about increasing the solubility of a gaseous solute like soda bubbles. Do we want something cold or hot to increase the bubbles in soda? Same thing with decreasing. Those should be the opposites for both of these. So go ahead and pause the video, continue playing once you have your answer. All right, so remember that these are opposite relationships. So remember that a cold solution is really good for things like gases, like we have more bubbles in cold soda. On the other hand, cold solutions are really bad for solids because, for example, less sugar dissolves in cold tea. And then the reverse, right? Hot solutions are really good for solids like sugar and hot tea, but they're really bad for gases like the bubbles in soda, the carbon dioxide bubbles in soda. Okay, this is going to be number 7. Go ahead and pause the video when you're ready to move on. All right, so today we talked about saturation versus solubility. Remember, saturation is a description, whereas solubility is a number. We talked about how increasing temperature also increases solubility of a solid solute because there's more energy to break apart that solute, whereas increasing temperature for a gaseous solute actually decreases a gaseous solute solubility because now that gaseous solute can actually escape. All right, this is going to be the objectives for today. So go ahead and pause the video and think about how would you rate your understanding today. Don't forget that if you are on this side, please make sure that you are reaching out to Mr. Bangle or Mrs. Sepulveda. Remember that both of them are able to help you with anything science related, so they can help you with your projects, with the future exam, or with understanding any of these concepts. All right, and don't forget to make sure that you submit your 5B notes, and I will see you later.